This is the Math 6 3.1 to 3.2 mid-test review for Chapter 3. So this is over algebraic expressions, writing them, and then evaluating them when given values. So our first questions say, identify the terms, coefficients, and constants. So our first example, or our first expression is 6q plus 1, and we're going to be asked to list the terms, coefficients, and constants. So when we're looking at our expressions, we can split up this expression by drawing a line in front of any plus sign that we see. And since we've taken that expression and now cut it into pieces, each piece is a term. So our terms are 6q, and that positive 1, so we can just write a 1 there. Now coefficients are the number that is connected to our variable. So here, the number connected to our variable is a 6. And then our constants are numbers that are not connected to variables. So they're just our normal numbers, numbers that aren't connected to anything. So here it's that positive 1 or just a 1. And since we're just identifying here, we don't have any values to plug in. This would actually be our final answer, and we can move on to our next problem, which is the same type of question. It's asking us to list terms, coefficients, and constants. So again, I'm going to draw some lines so I can cut this expression into pieces, so it's easier for me to see my terms. So I have a 3r squared, I have a positive 4r, and I have an 8. So those are my three terms. Coefficients, again, are the numbers connected to our variables. So here we have a couple. We actually have a 3 and a 4. So we're just listing the coefficient, which is the number connected to the variable. And it's a number in front, so we wouldn't count this exponent here. And then our constant, again, is the number that's not connected to our variable. So here it is an 8. So we've listed our terms, coefficients, and constants. Our next question says to complete the table. So here, we've done stuff similar to this, except now we've just put it in a different form. We're given values for x. We have a 1, a 2, and a 3. And then we have this expression that we're going to be using. So this middle step is our plug-in step. So for our first problem, we have x plus 6 when x is 1. So I'm going to plug in 1 for x. So I have 1 plus 6. And then our answer is where we list once we've evaluated. So 1 plus 6 gives us 7. Again, here x plus 6 is still our expression, but now our x is 2. So we're going to plug in 2 for x. And we have 2 plus 6, which gives us 8. And then again, that x plus 6, except now x is 3, so we're going to plug in 3 for x. So 3 plus 6 gives us 9. Our second table is a little bit more complex. We have an extra step in here. We have a different expression here, 3x minus 5. And when we have that 3x next to each other, that means 3 multiplied by x. So I'm going to plug in my values of x here in parentheses. So I remember it's 3 multiplied by that number, not 3 right next to that number. So our first is going to be 3 multiplied by 3 minus 5. And when we are doing these types of problems, it's now going back to order of operations. So we're going to do our multiplication first, which is 9 minus 5. 9 minus 5 gives us the answer of 4. So again, now our variable value is 6. So 3 multiplied by 6 minus 5. We're going to do our multiplication first. We get 18 minus 5, which gives us 13. And then lastly, our value is 9. So 3 multiplied by 9 minus 5. So we have 27 minus 5, which gives us 22. The next question say write the expression using exponents. So our first one, we're multiplying s's. And so we have 1, 2, 3, 4 s's. So when we write this as a power, we're going to have s as our base and 4 as our exponent. So s to the 4th would be our final answer there. Our next question is 2 multiplied by a few t's. We have 1, 2, 3, 4, 5, 6 t's. So we know it's going to be t to the 6th power. But we have this number here, and we're multiplying that by t to the 6th. So we're going to add that to the front of our t. That means 2 multiplied by t to the 6th. And in this case, that 2 would be called the coefficient. And we're done with both of those problems. Here we're evaluating. So now we're going to be plugging in values. We're given A is 8 and B is 2. So our first expression is A plus 5. So our first step is to have that problem written down. Our next step is to plug in our values. So 8 plus 5. And then we are actually going to evaluate, meaning find the answer. So 8 plus 5 gives us 13. And that's our final answer for that one. Our second problem is A, B. And when numbers are next to each other or variables are right next to each other, that means multiplication. So it's A multiplied by B. So I'm going to plug in 8 for A, and then I'm going to plug in 2 for B. So this is 8 multiplied by 2, not 82. So 8 multiplied by 2 gives us 16, and that's our final answer there. And then our last example like this is A squared minus 6. So I'm going to plug in 8 for A squared minus 6. So 8 squared means 8 times 8, not 8 times 2. So 8 times 8 gives us 64 minus 6. And then 64 minus 6 gives us 58. So our final answer is 58. Now our next questions here say to write the phrase as an expression. So we're going to be given a phrase, a sentence, and we're going to have to write it as a math problem. So here it says 10 less than a number G. So I'm going to underline the keyword or phrase, here's less than, and I know that's subtraction. But remember, less than is that tricky phrase. So 10 less than this number G, we have a value of G and we want 10 less than that. So we would actually write G minus 10, not 10 minus G, G minus 10. So less than is a little bit tricky. The next one here says the quotient of a number X and 7. So quotient would be our keyword. That means division. And then X and 7. So I know a lot of people are going to write X divided by 7, which is totally fine. But remember, another way to write this and what you're going to see later on in the year and years after this is going to be X over 7. Because that fraction bar also means division. So both of those are correct. This second one here is what you're going to see more often. And then a third example says the sum of 12 and a number Y. So our key word here is sum, which means addition. So we're going to take 12 plus Y. Okay, a word problem. It says the expression 15A plus 12C, so I'm going to box that because I know that's important, is the cost in dollars of admission at an amusement park for A, adults, and C, children. C stands for children. So I'm going to make a note of that really fast. A equals adults, and C equals children, so we can remember that. It says find the total cost for 5 adults and 10 children. So I'm going to have 5 equals A and 10 and 10 equals C. So now I'm going to use that expression 15A plus 12C. So I'm going to plug in 5 for A, so 15 multiplied by 5, plus 12 multiplied by 10. So here now we're actually going to be doing some multiplication. So 15 multiplied by 5 gives you 75 there. Plus 12 multiplied by 10 is 120. So when you add those two up, if you have to do that to the side, you should end up getting 195. But that wouldn't be our final answer because we're talking about total cost. So we know this is in dollars since it tells us in the very beginning in dollars. So your answer is $195. And then our last word problem is actually going to have us write an expression. Write an expression and then use that expression in order to solve for a certain amount. So it says to rent a moving truck for the day, it costs $33. So that's kind of like your flat fee. You have to pay the $33 to get that truck, plus $1 for each mile. And each is a really important word there. So it says write an expression for the cost to rent the truck. So no matter what, we're spending $33 to buy that or to rent that truck. But then we have to add on because it says plus $1 for each mile. So I'm going to put M for miles. M equals miles. Oops. Keep hitting that button. So 1M. And that means for every mile that I drive, I have to spend an extra $1. So 1 times however many miles I drive, plus that $33 fee that I have to pay just for renting it. Now here it says on part B, To use that expression, it says you drive 300 miles. How much do you pay now? So I'm going to use this expression from above. That 33 plus 1, and then here, 300 equals M. So I'm going to plug in 300. So I have 33 plus 300. So total, that's 333. And now again, remember we are talking about dollars since it's cost. So it's $333. So in order to rent this truck and drive 300 miles with it, it would cost us $333. So that's the end of our review video. Rewatch anything that you think you need extra help on so you can hear that explanation again. Hopefully you wrote these notes down in your notebook. And then good luck studying.